Hi, welcome back. This is Math 195. We're going into section 3.3 now. It's about slope. So slope is the measure of the tilt of a line. So for instance, here's our XY plane, and here is a line. So the way to think of it is rise over run. So you kind of pick a point on the line and you see how far up it goes, that's the rise, and then see how far over it goes, that's the run, and then the ratio of those is the slope. Okay, so the slope is the rise over the run. Okay, for finding out the actual numerical value, what we have to do is consider the ordered pairs on the line. So let's say the first x coordinate is x1, then this associated y coordinate will be y1. So the point is x1, y1. And then for the second point, let's say that's x2, and then the associated y coordinate there is y2. So to get an actual value for the slope, what you're doing is taking the difference in the y coordinates, that's the rise, divided by the difference in the x coordinates, which is the run. Okay? It's extremely important in math. We talk about slope all the way through pretty much everywhere. All the way through Calc 3. We're still talking about slope. We have different names for it then called the gradient, but it's a measure of a rate of change. Okay, and rates of change are all over the place in science, so it's very important. Okay, so anyways, there's four main types of slope. Let me first talk about a positive slope. So m is greater than 0. There's this kind of tilt, which is, you can think of it, if you want to think of slope as speed, this would be a very fast speed. Okay, so you're going way up and then over by a little bit. So the numerator is going to be a big number. So if you thought of slope as kind of a speed, this would be a very fast measure. You kind of, okay. So compare that to this version where you have a line that has a very small tilt to it. The slope is still going to be positive here, but as far as the speed, so if m is speed, this is going to be kind of slow. So the one on the left is fast, and the one on the right, again, if you think of slope as speed, that's going to be slow. Okay. Then from there, you have the negative slopes. And in the terms of maybe a physical situation, if you have a negative slope, its direction is what's really changing. So instead of going forward, maybe you're going backwards. And again, you can compare different types of negative slopes. So the first case would be something like we could put a number on it, right? So the first one maybe it's -4, and then the second one we would say is maybe it's something like -1. So in the picture above, if I wanted to put some numbers on them, I'd say maybe that first one would be like a 5, and then the second one would be like a 1, like maybe 5 miles per hour versus 1 miles per hour. Okay. Okay. And then in addition to those slopes, you have a slope of 0 and then undefined slope. So if the slope is 0, that's when you have a horizontal line. Okay, so there's no change in height. And then if the slope is undefined, that's when you have a vertical line. Okay, so those are the four main types of slope. Again, important in physical applications and in science, and these ideas carry through all of mathematics. So you can think of slope as a rate of change, like speed of a car. You could think of it as any rate of change, like the number of gallons per minute that you pump into your car. You can think of it as the number of crimes per square mile. You could think of it as the whatever science you're in, the number of babies born to a snow leopard per 5 years. You know, it's all over the place. It's used all the time. Okay, so let's get into the homework then. And the first couple of problems, they're just using the definition of slope to basically determine the tilt of the line. And when I do these, it's always the same kind of process. I don't even think y2 minus y1 anymore, really. I just think this guy minus this guy divided by that guy minus that guy, right? I do the little bracket things. So the slope is 8 minus 5 all over 6 minus 1. I'll be 3 all over 5. So it's a positive slope. And we could type that into our machine. Check it, make sure it's okay. So does the line is positive, it has positive slope. It's not going up very fast, so it's not tilted in an extreme way. If you think of it as the side of a mountain, it would not be very hard to go up this mountain. But anyways, it's increasing, right? The line is going up, the line is rising from left to right. Okay. You want to be careful when you start getting some negatives involved. Let's go back, sorry, to number 2. So number 2, here we have negative 4, 6, and then 3, 5. So the rise is going to be 5 minus 6 all over the run, which is 3 minus negative 4. So you have that minus minus in the denominator. Let's simplify the numerator. 5 minus 6 is negative 1. I'm going to rewrite this as a plus. So I try to do too much in my head, I just screw it up. So in my case, some people are different, right? So anyways, negative 1 all over 7. So in this case, the line is going down. It's not going down very fast, but it is going down. Basically, it goes down 1 unit for every 7 units to the right. So the slope is negative 1/7. And then they want to know it's falling because it's negative, right? It's going downwards instead of upwards. This one, it looks like it has 2 of the same values in the y-coordinates, so it's probably going to be, you know, vertical or horizontal. If you think it through, you'll note that it's going to be horizontal, right? It's that same y is always negative 8. That'll be the equation of the line. But anyways, let's do it kind of like a computer would without thinking too much. So negative 8 minus negative 8 all over 3 minus 6. I'm going to simplify by changing the minus minus into plus. And you see in that numerator, I'm going to get a 0 out. Anything, 0 divided by anything except 0 is just 0. So this time the slope is horizontal. Okay. So the slope is 0. Excellent. And then the line is horizontal, like the horizon. Right? Okay. Let's skip this one. Okay, so let's try this one. And you probably can see why I'm picking this guy. It's the other type of slope that we hadn't talked about yet, right? It's the undefined slope. So for these guys, it'll be business as usual in the numerator, so 1 minus negative 9. But in the denominator, you'll see a cancellation, right? So negative 5 minus negative 5. I'm going to clean it up a bit. So 1 plus 9 in the numerator, negative 5 plus 5 in the denominator. So in the numerator, I have 10, and the denominator, I have 0. This is undefined. We can't divide by 0 in math. So in this case, it's just going to be a vertical line. And so we'll put the slope is undefined, okay, and then it's vertical. Okay. All right, let's see what else. Oh, okay, so now in these problems, what you're doing is using the picture in order to determine the slope. And we'll probably zoom in here, kind of get the points. You could read off the coordinates off the picture if you want to just use the formula. So this problem 6, it looks like negative 2, comma, negative 1, and then you have 1, 1. So you could literally go to your slope formula and go 1 minus negative 1 all over 1 minus negative 2. So that's going to be 1 plus 1 all over 1 plus 2, which is 2/3. But you could also read off the graph, right? So if you, let me redraw it over here very quickly. So we have 1, 2, down 1, and then 1, 1. So how do I do this without actually having to do the computations, right? Well, you're just going to count out the rise. So I'm going to go up 1, 2. So I went up 2. And then I'm going to go to the right, 1, 2, 3. Okay, so if you go up 2, that means the numerator is positive 2, and then you go right 3, so you'll run 3. And you get the same answer whichever way you do it. I think it's easier just to read it off the graph, but you can do what you want. As long as you get the right answer, I'm usually pretty happy with it. As long as you get the right answer and you're not cheating. Right? So, all right, so this guy, it looks like we're going to go down 6, 7, 8, 9. So that would be, because I'm going down this time, that's going to be a negative 9 in the numerator. And then I'm going to go to the right, it looks like by 7. So negative down 9, right 7. I'm always thinking going to the right when it comes to the run. Okay, so down 9, and then to the right 7. Oh, it did. Okay. Same spiel here. It looks like it's going down 7, and then to the right 5. So down 7, to the right 5. And so on and so forth. This is another down 2 over 1. This horizontal line, the slope is 0. There's no rise in those cases. Vertical line, the slope is always undefined in those cases. If you want to, you can get the coordinates by reading the graph and then use the definition. Now the next set of problems are on parallel and not parallel lines. So if they are parallel, the slopes of the two different lines will be the same. So you'll get a slope for the first line, and then you'll see it equals the slope of the second line. So this is the parallel case. And then the perpendicular case, which we'll see here in a bit, perpendicular. They say if you multiply the two slopes together, you'll get -1. But another way to think of it is that the slopes are negative reciprocals. So if you have M1, that will be the same thing as the negative reciprocal of M2. So you just flip M2 and then make it negative. If it's not one of those cases, it's neither. Okay, so anyways, it's a lot of computations. Let's look at number 12. So we have 0, -8. And one thing they don't want you to do is to graph these things, okay? Because the graphs can be a little bit misleading if you're like me and you're not using graph paper, you're not using a ruler. And even if you were using a graph paper and rulers, every once in a while, if the lines are just kind of look like they're parallel, you'll come to the wrong conclusion. So it's better to do it in this way than it is to graph the lines. So if you do it on my test, you graph the lines on my test, I will not give you full credit, okay? Okay, so anyways, the first line, I'm going 1 minus -8 all over the second line, -5 minus 0. That'll be 1 plus 8 all over -5, which is 9 over -5. And we don't like to put negatives in the denominator, so we'll just write it in front. M2 then, we have 6 minus -3 all over -13 minus -8. So I have 6 plus 3 all over -13 plus 8. That'll be 9 all over -5, which is the same as 9. So these guys have the same slopes, so they must be parallel. Okay. All right. Same game here. They just want you to, okay, so, and then they move to perpendicular lines. Okay, so number 14, we have 2, 4, 1, 1. And then on the other line, -3/8 and 0, 7. So I get the first slope 1 minus 4 all over 1 minus 2. That will equal negative 3 all over negative 1. Negative by a negative is positive. 3 over 1. 3 divided by 1 is just 3. And then the second slope, oops, butchered the m. That will be 7 minus 8 all over 0 minus negative 3. So it will be 7 minus 8 is a negative 1 all over 0 plus 3. So it will be negative 1/3. Okay, they are negative reciprocals. You can tell because 1 is the negative, is just the flipped. So if you have 3, 3 is the same as 3 over 1. And then if you flip it, it's 1 over 3. And then if you make it negative, it's negative 1/3, which is the other slope. Okay, so that's one way to view it. So we know it's perpendicular, but another way to look at it is just to multiply them together. And if the result is negative 1, which it is in this case, then they are perpendicular. So you could say perpendicular. You can also use the upside down T symbol if you want to. That also means perpendicular, and I will know what you mean by that. Okay. So let's check it. Yay. Good to go. Sometimes a little more difficult to tell if it's kind of closely perpendicular. So maybe you multiply the numbers together and you get a positive 1. So just be aware that that could be an issue. So like this problem, it's kind of, you know, is it parallel, perpendicular, or neither? Let's try this guy. It's got 10, 6, and 5, 10. And then the other line, 4, negative 8, and negative 1, negative 4. Okay. So the first slope, 10 minus 6 all over 5 minus 10. So that would be 4 all over negative 5, or negative 4/5. And then the other slope, so 2, negative 1 minus 4. Whoops, I screwed that up. Negative 4 minus 8, negative 8, all over negative 1 minus 4. That'll be negative 4 plus 8, all over negative 5. So that would be 4 over 5. Okay, so they kind of look like it's a mix of parallel and perpendicular, right? Because sure, they're not quite equal, but one is a negative of the other. But you see that in either case is really holding. So they're not parallel. It's all right, not. And then the parallel symbol is just 2 lines like railroad tracks. It's not parallel because negative 4/5 is not equal to 4/5. You know, barring any silly mistake. Oh, I did make a mistake. So it's positive 4 over negative 5. I'm so sorry. I'm just butchering this exercise. They're the same, so they must be parallel. Lines are parallel. I'm sorry. I did not. My mind is starting to wander on me. I think that's the issue. Maybe this one will be different. Let's try this one. So 17, negative 3, negative 9, 0, negative 3. And then on the other line, 0, negative 7, and 2, negative 6. So the slope will be negative 3 minus negative 9, all over 0 minus negative 3. And here I have negative 3 plus 9, all over 0 plus 3. It'll be 6 over 3, which is 2. Okay, and the other guy, let's call this first guy slope 1, slope 2. Negative 6 minus negative 7. And that'll be all over 2 minus 0. So that'll be negative 6 plus 7 all over 2, which will equal 1/2. So this is one of those ones that looks like maybe it's definitely not parallel, right? So it's not parallel, and it's because 2 is certainly not the same as 1/2, right? And then the question is, are they perpendicular? And you can see if they clearly aren't, because they're not negatives. The second slope is not the negative of the first. It kind of seems like they are because they're reciprocals, but you need negative reciprocals, right? So in other words, when I multiply them together, I just get positive 1, not negative 1. Okay, so it's a no one there. It's not parallel, it's not perpendicular, so you're just going to click on neither, okay, which happens. And then you know, more of the same. This one's kind of odd. You're asked to use the slopes to graph the lines. All of the lines are going through the origin in this case. So this is problem 19. And you're basically just using the slopes as a rise over run. So if you have -1, put the negative in the numerator like that. So you're going to go down 1 over 1. So down 1 over 1 will put you right here, and that would be your first line. And so on the graph here, hit the line tool, start at 0, 0, and then just count out the down 1 over 1 for your slope. Okay, that would be the first line. For the second line, I have -1/4, and I always think of the negative as being in the numerator, telling me either, in this case, to go downwards, right? So I'm going to go down 1 and then over 1, 2, 3, 4. And then that would be the second point, and you would graph that. So come over here. The 0, 0 is the first point, and then down 1 over 4, it is the second point. Okay. Slope of 0, that's just a horizontal line, so you can just pick 2 points on the x-axis. 1/3, so slope of 1/3. That means go up 1 and then over 3. So up 1, 1, 2, over 3. And that would be that line. So put 0, 0, and then up 1 over 3. Okay. And then finally a slope of 3. So to think of that as rise over run, you just rewrite it as 3 over 1. So you're going to go up 3 and then over 1. So you go up 1, 2, 3, and then over 1. And that would be your last line. Okay. So let's do that. 0, 0, and then up 3, 1, 2, 3, over 1. So we should have 1, 2, 3, 4 lines. 1, 2, 3, 4. Did I miss one? Up 1 over 3. I got that one. Oh, and then 1, 2, 3, 4. I didn't see the x-axis, so I think that should be good. Okay, and then we have some kind of application type problems. The deal here is that they're trying to think of your slope as a percent instead. So you want to convert it to a decimal and then convert it to a percent. And in general, so let's read the problem. In general, the following slopes expressed as percents are typical for each of the trail. Trail starts at an elevation of 11,645 feet. And then ends at an elevation of 9,694 feet. Okay, so you can imagine here at the top, 11,000, and then it goes down to 9,600. And then they tell you the, kind of the run, the movement in this direction is 14,563. Okay. Okay, so the top of the hill, you're at 11,645, and then you're skiing downwards on the hill, and then finally you get down to 9,694, and in the process you've moved over to the right by 14,563 feet. So the rise is going to be, in this case the fall, is going to be found by subtracting the heights. So the top height 11645 minus the bottom height 9694, that tells you this distance. Okay. Right. And then the run is just the 14563. Right. So it's the rise, or in this case the fall, and then the run is right here. Okay, so I'm going to go to my calculator and figure this out. 11645 minus 9694 was 1951. all over the 14563. And that's giving me 0.1, and I gotta see how far they want me to take the decimal to the nearest tenth. So 0.133 normally, but I have to round up because the next number is a 9. And then you're rounding to the tenth, but it's when it becomes a percent, right? So to make it a percent, you multiply by 100, and you'll get 13.4%. So the slope of the trail is 13.4. And then you could look at the table to figure out which type of ski trail rating it is. So it's a beginner ski trail. And okay. So in terms of slopes and hills, maybe you need to know to give warrant. If you've ever been on the Pennsylvania Turnpike, they need to reinvestigate some of those hills, in my opinion. But it's similar to the last problem. They want you to get the slope and basically turn it into a percent. So the slope is the rise, which is 2 feet, all over the run, which is 25 feet. And then you're going to your calculator, 2 divided by 25, 0.08. And then convert it to a percent by multiplying by 100. So that would be an 8% slope. So that's pretty simple. Is that it? Okay, I guess that's it. Well, thank you for watching as usual, and I will see you next time.